Okay, so I'm sure you've heard a lot about low floor, high ceiling tasks. The task that you just did is considered a low floor, high ceiling task. And again, if I wasn't now racing against time, couple of things make low floor, like make a task low floor, high ceiling. If you can draw a solution, it qualifies as a low floor. The high ceiling part of it is less interesting to me, but completely legit. But I'm hoping that when you think about that, so I want to go back to DeVoe was saying that she was drawing a picture, and wait, somebody else was drawing a picture when I first went into a room. Tracy. Okay, so we were talking about 6 rectangles divided into thirds, yeah? So I want you to get a picture of that in your head. Now, for those kids that need the high ceiling, I could say, how many thirds is that? How many thirds is that? 18, right. So if you're putting them into groups of 2, how many of them do you have?
9.
Right, so we can go directly from a drawing to, and you know, the reason you can say, if I have 18 thirds and I'm putting them in groups of 2 thirds, which is division, I have 9 thirds. It's like saying I have 18 apples and I'm putting them into groups of 2 apples. I have 18 dominoes and I'm putting them into groups of 2 dominoes. I have 18 children and I'm putting them into groups of 2 children. It doesn't matter whether they're objects or whether they're fractions. Because when the denominators are the same, they don't really matter. So that's a high ceiling, and we can talk about with that. Again, not a particular area I'm that interested in. If a problem can be solved through guess and check. Now, one of the things I heard the group talking about as I was in limbo was, what the hell kind of chart was he talking about? Can anyone think of a chart that you would use to solve that problem? What would the columns of the chart be? Well, you could have number of cups and a running total or an in-between total of how much mix have I used. So 1 cup, 2 thirds, 2 cups, 4 thirds, 3 cups, 6 thirds, or 2. And that relationship is something that will jump out at kids. Okay, so it's possible, if you can find a way to make a problem be able to be solved through drawing, guess, and check, or modeling with materials, that we can consider it a low floor, high ceiling task and create equity. This is one of the best examples of making a task accessible. So I did this with some 4th and 5th graders. What are some simple ways you could decompose 7/8 with addition?
One eighth plus 6/8.
1/8 plus 6/8, 2/8 plus 5/8. Of course, kids are going to say 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8. Yep. All fine. And I would encourage kids to put those up on the board. On the high ceiling end, you're going to get kids that will use equivalent fractions.
Like a half plus 3/8.
Exactly.
Yeah.
Or even a half plus a quarter plus an eighth. Like, they get really involved in doing this. So in this instructional sequence, we had them decompose 7/8. We had them decompose 5/6 because it gets at some other fractions. And then we had them find ways to write a half. And we had 4 kids on IEPs in this particular class. And these 3 days of instruction were the first time they'd been working with the whole class. And they were able to fully participate. Their versions of a half were things like a half, 2/4, 3/6. Other kids had a million, 2 millions, and some other crazy stuff. But when they went up on the board, everybody's work was up there. There was a way for every kid to access the lesson. And that's what we mean by scaffolding. Pre-thinking through the task you're going to be working on as a class to think about how you might provide access. So I've written a lot about this, but the idea here is that math is understanding math concepts is a process of sudden insight. And in the games workshop, we talked about the best condition for a student to be in is to be relaxed and curious. And so when a student is anxious, they actually lose working memory resource. And of course, you know that most of your strugglers are anxious most of the time. So it's this fine line you have to walk between the struggle, because they've got to struggle a little. There's no insight if you're not trying to understand something that you didn't understand before. So you've got to provide some struggle, but not have it be overwhelming. And then immediately upon recognizing insight, I think the student has it. There has to be a way for them to talk about and reflect on what they understand, because the talking about it, so the way the process works is that your brain is put into a state where it's ready, this curious state. It's highly detailed in literature on neuropsychology, sometimes called the flow state, but it's a low alpha high theta brainwave state. And when you're there, then you have access to thinking that you don't otherwise. Once you have the insight, in order to have it be more than just a happy memory, it has to be connected to other parts of your thinking, to long-term memory. And the way you do that is by talking about it. The dialogue and reflection in classroom discourse is about solidifying new understanding to previously understood ideas. So it's all really, really important. This is a little diagram I sometimes use to talk about this. We present a problem or task, and in the last workshop I was talking about using games as a way to do this because they're very effective that way. The disequilibrium is there's something I want to know but I don't know. And then we have this productive struggle. And for those of you that are interested in this sort of thing, there's a lot written about productive struggle. There's a moment of insight as a result of the productive struggle interacting with the right brain state. And sometimes when I've talked more about how all this happens, there's a little feeling that this idea of the right brain state is a little woo-woo. But Csikszentmihalyi won the Nobel Prize for writing about this. The example I like to give, though, is Navy SEALs are trained to achieve this state even in combat. So they're taught to use brain monitors to achieve the state on their own. Then they have to achieve this state, this flow state, while they're exercising, and finally they have to be able to achieve this state while people are shooting guns at them. So the Army believes there's enough empirical research to invest millions of dollars in this. All we're saying is if a kid needs to learn a new mathematical concept, in terms of their state of mind, it has to be in the general vicinity of this alpha theta state. Then the reflection and discussion is about refining the idea, but more it's about building connections to long-term memory. Yeah, so this is my big, it shouldn't be news, but it is news. So especially when you're dealing with kids with profound learning challenges, you still have to let them do the work. And if there's any place where students are drilled and trained in particular procedures, the greater their needs are, the more that tends to be the case. And I understand the impulse. It's a practical impulse. If they've got to take a test, I'm going to show them how to do the thing they need to do, and we'll practice it over and over again. The problem is they don't get the advantage of the brain development that comes from inquiry. So I'll give you an example from a case we really dealt with. We had a student who was in 5th grade, and he had an IQ around 50, has an IQ around 50. And when we interviewed him, his response to the question, how many do you see, was to count no matter what. Even if there were 2 objects in front of him, he would still count. And the reason was really clear, because every teacher he had taught him that when you see a group of objects, you count. And so the sum total of what he understood about numbers after 6 years of school was that he could count objects into like 12, 13. He had no more strategies for dealing with them beyond that. And he could recognize coins because money was on his IEP. Okay, so we met with his folks in October, I guess beginning of October. And we put him on a program where he had to learn subitizing. All that he had to use inquiry, had to develop his own understanding of 10 frames and how 10 frames are put together and how to recognize 10 frame groups and recognize one more and one less and what doubles were. And 4 months later, he was decomposing sums to 20 on his own. Right? So he made the equivalent of 2 years worth of growth in 4 months just as a result of the instruction. And for the record, none of us were doing the instruction. His regular special educator was doing the instruction. It's just the direction of the instruction. What they were doing was different. And that's a fairly critical element here. It's actually what I'm really asking you to consider most about what we're doing. There still needs to be discovery. There still needs to be inquiry. So it's all about the question. It's always about the question. I love watching my students when they're in their field work because they know, they've heard from me, ask, don't tell 10,000 times. And yet they're sitting with a kid who's not getting it. And you can just tell they want to say, no. Look, this is how you do it. And they also know that if they say that, I'm going to say, yeah, no, make another move. But they can't come up with the question in the moment. It's great. I think sometimes I see smoke coming out of their ears. So what we have found, there's a blog post about this too. When a kid is stuck, you're trying to ask a smaller question. So we think about the learning as intuitive leaps. So if they can't get, well, how would you show me this number? Maybe you can ask a question like, well, if you showed me with 1s and 10s, how many would it be? Or if you counted out this many, how many would there be? Or if I were to trade, is there a way I could trade to make this number different? Finding the smaller question will help. And initially, it's a really hard practice, but it's a pretty easy practice to get in the habit of. And you start to realize, I'm whittling down my question, and you'll know you've gotten there because they make the leap. If I could give you one piece of advice to take away from this as practitioners, it's to look for the leap, to look for the recognition that they understand what they just did, and then have them talk about it or talk about it with them. Offering a pattern is another really good way to support inquiry, right? So I'm working with a 6th grader and I want her to multiply 23 by 10. And so I say, so we're doing some mental math. What's 23 times 10? And she goes, how would I know what 23 times 10 is? Right? So I could say, what's the thing everyone is so tempted to say? Just put a 0 on the end. Right? We all want to do that because it's so easy. And they'll do it. That's the problem. They'll do it. They don't want any idea why they do it. So instead, what I say is, well, I make a chart. What's 2 times 10? What's 3 times 10? What's 4 times 10? What's 8 times 10? What do you notice about the number you're multiplying by 10? What's 12 times 10? And you can watch the moment when they say, oh, you just add a 0. And then because I work with Sandy Stanhope, I always say, well, you're not adding 0. Because adding 0 does not give you this number. He goes, well, so you're adding a 0 to the end. You're putting a 0 on the end, right? Because it's 10 times more, right? Okay. Another really important way to support kids to do inquiry at grade level is to pre-investigate the concept before the class does it. This is very powerful. If you're the kind of school that's doing main lesson and math menu, what I recommend all the time is that you use a part of math menu to investigate the next day's concepts ahead of time. So if you're going to do a number talk and you've got these kids that are never participating in number talks, do the number talk with a small group of them at menu the day before. And then when it comes up in class, they have ways to contribute that are not contrived, that they've already been able to think about. And of course, I probably don't need to say it, but I'll say it anyway. No model, no understanding. Doesn't matter whether they're on an IEP or not. If a kid can't demonstrate the concept with a model, they don't really understand it. Sort of the first rule of specialized instruction or clinical interviews. No model, no understanding. So, we're going to provide, this is a sort of cumulative slide, a wrap-up slide. We need to get everybody involved. Classroom teachers, these students are their students too. They're not the para students. They're not the special educator students. They're everyone's students. And I'm hoping you can consider these elements of rigorous scaffolded inquiry for the kids you work with. Okay. I've got all of, I'm willing to stay here forever, but we've got time for questions if you have any. It's a lot of information in a small period of time. Okay, well, the slide deck will go up with, anyway, this talk is already posted on All Learners, and it's also posted at the Vermont Council of Teachers of Mathematics website, so there's more information there. There's specialized instruction workshops that are free from the state, including one that we'll be doing in the spring with the Vermont I-Team for kids with significant learning challenges, so take advantage of those. And of course, if you have other questions, don't hesitate to contact me at ALN. That's it for today. I'll hang around in case any of you have questions, but otherwise, I hope the conference has been good for you, and good luck on choosing your final session.